My name is Jasper Chow. I'm a dev manager here in Vayner. So on behalf of the company, welcome everyone. It's good to see you guys. Excited to see you guys, as Chris and Shaheen put it, the second biggest event tonight in Toronto. So yeah, also thank you for Tech Tank to give us the opportunity to host the event. So hope you enjoy the environment and the food there. Um, I'm going to give a brief introduction of the company. So this is a picture that we took earlier this year in the space over there. I like this picture. It's like everyone in the company. And I think I'm here somewhere. Oh, here, this guy. So yeah, we are Vayner. We provide cloud-based financial planning and analysis software to our customer. So we are natively integrated with M365 technology and Excel. So we serve customer bank, financial institute, pro sport franchises, educational institute, charity. As long as your company use Excel, then Vayner is the perfect partner for you. For you or the company. So we are Toronto-based. So you're right now in our head office. We have a UK London office and also an India office. We are mainly distributed workforce. We have team members in different cities, but some people do come in the office and work, and we are highly collaborative. If you have any questions, post it on Slack. And we do have one team mindset, and people jump on and get things done for you. So we have a tenant team booth behind you. At the end, there's a QR code there you can scan and see our career opportunity here in the company. So, and we have a few folks here. Feel free to talk to us after the event, and just ask us any questions. Next. So yeah, a quick slide on a bit of my journey here. I joined the company 3.5 years ago. It was turning from a startup to a scale-up company. So I just barely missed the 10 years party, unfortunately. But afterwards, there's a lot of very positive change. So we strengthened our leadership structure. So we have experienced leader like Hugh, CTO, and Brandon joining. He's a senior VP of technology operations, and really turn things around and consolidate or refine our org structure, building new insights and industrial experience to the company. We have foundation quarters to help us to tackle some of the tech debts that we have in our backlog, and we introduce hackathons to just unleash the creativity of our developers. We also focus on AI. We recognize this as a disruptive technology that brings a lot of change to the industry, and how we do things. So we have introduced GitHub Copilot for increasing our developers' activities. So it's just a few things that I list out. Later on, last year we established a unicorn partnership with Microsoft. So it's further strengthen our strategic bonding with Microsoft. And this year we reached 100 million ARR, so which is a pretty good milestone. A bit on myself and the team. I'm, I guess, one of the 12 product dev team in the P&T department. So the project started with kind of internal hackathon project mid last year, and then later we form a team and productize the feature. Because of the partnership with Microsoft, we have a collaboration with the OpenAI team, in Redmond last year, which is pretty exciting and really boost our knowledge and also productivity on the feature development. And later on, mid this year, we GAL Copilot feature. Recently, we start on second AI team and help to bring more value and assets to our customer, and expand our AI features offering to our customer. Today, our speaker Kevin and Shaheen has been with the team since day one, so they have a lot of good insights, and they're development journey to share with the team. So hopefully you enjoy the evening, the topic, and the discussion. Thank you. Back to Chris.
Thank you so much. Why don't we just get the speakers up here, Kevin and Shaheen.
Hi, everyone.
Oh, Jesus. Hello. How are we doing tonight? Woo! All right, let's get this show on the road. I need to share my screen first. There we go. I guess intro. I'm Kevin. I'm a staff developer here at Vena. Been here 3 or so years. Jasper summarized my time here pretty well, so thanks, Jasper. Been working on this project, I guess, for the last year, and this was a talk that we gave internally maybe a few months ago. It was originally called "Building Blocks of Generative AI Applications," just covering some of the basics that we thought were useful as we built Vena Copilot, and we updated some of it, but a lot of it's still the same. So if you guys have experience working with these tools, some of it might be familiar, some of it might not, but you have to sit through it anyway. So.
Great. Thanks, Kevin. Hi, everyone. My name is Shaheen. I'm a senior software developer at Vena. Really cool place to work, so if you're interested, go check us out later. And yeah, I'm also on the AI team. Also been here for 4 years in total, 1 year in the AI team. And yeah, we'll try to share with you some of the interesting things we've learned over the course of becoming a Gen AI mans. So let's get started.
All right, so if this slide works, all right. Y'all see that all right? Kind of? All right, so we have an agenda, as all presentations should. We'll start just basics. Chat completions, have a brief soiree into agents, the world of agents, the new hotness, whatever, with Semantic Kernel. It's a framework for Microsoft. I'll get into that. And then we'll talk a little bit about Retrieval Augmented Generation, which is, I think, in the title of the talk, so we will talk about that. And then if there's time, we'll talk about evaluation methods for Promptflow, with Promptflow, but we shall see. Right. So what are chat completions? This is, I don't know, gauging the experience of the group, but not just a quick summary of what it is. These refer to the responses generated by language models like GPT-4, GPT-4o, whatever else is coming out this week. During a conversation or interaction with users, the responses are crafted based on the text that you put in, the previous messages that have been sent in, what have you. But it all sort of predicts what messages will come out based on all this information you pass in. So what are the message types? Again, if you guys have used OpenAI's API or any of them, a lot of these terms will sound familiar, but there's 4 or 5 main types. There's user messages, so it sounds exactly what it sounds like. So what are user messages? Oh, Jesus. I pressed a random button. User messages, yeah. So example, how do I make an omelet? Yeah, user message. System message. So these are instructions that you'd provide to guide the AI's behavior. So if you wanted to give like a persona to your AI application, you can say like, well, you are a British chef, or you have a short and fiery temper, and the model will weigh the instructions you put here typically more than the other message types. Assistant messages, these are stuff that comes back from the model. An example of that would be like, make the bloody omelet, you donkey, or yeah. So that's that's the user message. And here we just have a short example of how it looks like with Olama. I'm not going to run this because it takes a while to run on my computer, but you can sort of see what the response there is. So in this example, you have two messages in your chat history. One is the system message, and you can also name your messages as well to identify who the roles are in your chat histories. It makes it a little bit easier to manage if you have a long history. So that takes me to structured responses. So these are mainly the tools that we use here at Vena. It's very, our approach to using AI is like, we like structured workflows with like expected inputs and outputs, because we like predictability in our systems, and AI is sometimes not predictable, but we like predictability, and that's why we like JSON and structured output. So what does that mean? So JSON mode, I think, I don't know when it came out. It probably came out like last year from OpenAI, but this is a capability where if you specify in your system message, say, I want JSON of this particular type, you would have to give a few examples of like the structure that you're expecting, the type information, all of that sort of within the prompt itself, and then sort of pray that the model will give you back valid JSON that is the structure that you asked for originally, and hopefully will fit nicely with other parts of your system, which may or may not always happen. So a lot of formatting and examples are quite important here. So here's another example again with the llama. I'm not going to run this, but oh, maybe I should run it actually. Let's go down, because I can't scroll down. Oh, okay, I ran it before. So here's an example. So the formatting is important here. So you give it like, so I'm asking for a set of breakfast dishes, and I want it in this specific structure. I want a dish array with name and style pairs for each object. And then this is a pretty contrived example, but you can see how you can sort of chain these together to build different parts of a workflow in your system. And once you do that, let's go back to the yeah, so that's JSON mode. The next sort of phase in that journey is structured output, and this so since when did we give this talk, in like July or something? So this they released a newer version of structured output after May 2024. So I specify that this information was fresh as of May 2024, but the next sort of phase of integrating AI into our system is this structured output. So why do we like structured output? Because we like types. Types are important for bringing some semblance of order to an otherwise chaotic system. And all these examples are in Python, but in our application we use a combination of Java and Python, but Python is a bit shorter to show in slide form at least. So Pedantic is the, I guess, de facto type validation library for Python, and it's powered by type annotation. So if your code base already has types, if it already has sort of annotated classes, then you can kind of get a jump start on integrating your existing logic into AI. So what does this look like? We have a class that contains a list of dishes. So this is the same example from before, and you have a class representing a specific dish. You have a description of what those things should be. And oh yeah, there's also, yeah, so pre May 2024, there is this library called Instructor, which was pretty good. It was like a shim on various LLM providers. So it's OpenAI, your Coheres, your Ollama, Claude, and it wraps the existing client, but you can give it an actual type, so that when you're making chat completion calls, it'll return the data as a type instead of just JSON that you kind of have to parse, you kind of have to guess and hope that it's correct. It's much nicer, like just from a developer ergonomic perspective, to work with types. Can I run this? Oh, let's run this. I don't have to run it. So yeah, this is the same example. So it's like the prompt is the same, and the only thing that's different is that we pass in a type, and then once you're working with it, you can treat it as if it's any other object in your current application. So just sort of showing an evolution. No, I guess, yeah, like an evolution of how we tackled this problem in our project. And then now we are in post May 2024. What happened post May 2024? GPT-4o came out. GPT-4o Mini came out at some point, and they supported this. They supported this new thing called JSON schemas, and it kind of bridged the gap from where Instructor left off. So before you had to use a library to tie the types together with your chat completion calls. Now it's sort of baked into these two models at least. So what does that give you? It gives you all the same benefits as instructor, right? Like it would give you reliable type safety. Oh yeah, right, go back. I guess the other nice thing about using pedantic and instructor is that if you have validation errors, the library would sort of try to self-heal. Like because you're using pedantic, it'll give you validation errors if the model produced like a field that didn't match one of your criteria. So it would try to self-heal that way. I have no idea if OpenAI does the same thing, but it's nice to have one less library in your. It's nice to have one less dependency. I'll put it that way. And yeah, the other nice thing about this is that the prompting is simpler. You don't have to provide examples in your prompt as long as you give the annotated type, because the type itself would have the annotations that that the model needs to infer what the output should be. So this next example I stole from the OpenAI docs. They have two classes here, one called STEP, one called Math Reasoning, and the example here is just your math tutor break down this math problem and guide the user through step by step. So that it's the same sort of syntactic sugar here. You'd give it a type, and the way you deal with it is similar to before, except now you don't need a library, which is nice. So in this example, you'd get back a list of, what are they called, steps over a math reasoning class, and you can iterate over it as such. And the next sort of useful thing that we have in our tool belt is function calling. So function calling is where the model is constrained to predict which functions and arguments should be called to achieve a task. You can give multiple functions for a model to guess what to call, and it'll try to figure out like in what order and what arguments to call for you. And this is useful for like I guess tool calling scenarios where you'd give it like these sets of things that agent is capable of doing, and you sort of have it do the planning process for you. So another sort of contrived simple example is we have two existing functions in our code base. Say our code base is a weather Google search app. And these are two methods that take some parameters. So how do we get the LLM to intelligently choose which of these tools to call? Because imagine you probably already have an application. You already have methods and business logic that you know work. You know how to use them. So how do you integrate it into an LLM? So you would do it like anything in software engineering. You would need documentation. So if you've documented your methods, if you've documented your code base, which I know you have, then this should be a relatively low bar to jump over, right? I guess if you don't, so this is like the Open API spec. So this is like a format that's very widely known and accepted for documenting APIs, and we use this same spec to pass to OpenAI to determine what tools to call, because this has a lot of good information, right? You know what the required fields are, you know what the type information is. The descriptions are also quite important here, because you kind of want something to be succinct and like descriptive, but not too wordy, because if your descriptions are like paragraphs of text, then that's going to eat up most of your context. So it's important to like be precise, but not too verbose. So here's two simple tools, and the way that you'd call it is again with another property here, where you give it an array of tools, where these two things are Open API specs, and then from there the model will return their own interpretation of what a function is. So this is just a simple function class that has arguments that will be called. So at this point, none of your code has been invoked yet. You still sort of have to do the glue work of like picking out these functions, finding out which functions are in your code base, calling them, and then making sure that your whole system doesn't explode. And here's another example, pre-May 2024 with instructor. So I really like the instructor library. I'm a big fan of type information, if you can't tell by now. Same example. except now you define your the functions that you can call as classes. You document your classes with what the potential fields are, and then you can pass in an iterable of either of these classes. So it's a union of the two. So it's the same sort of information, except now you get back like instances of the classes in your code base instead of like a random function object. So now from here, you can actually call these functions after this line, after that line. So the gap is a bit shorter, but you still have to call it explicitly. You still have to do checks and whatnot, pre and post checks from before you call your existing logic, because you want to make sure that it doesn't like spam your services and take stuff down, right? So now we're in post May 2024 structured outputs. What does this look like now? It's the same thing, except maybe it'll be better if I show it here. I'll just show this instead. Yeah, so now it's like natively supported in the API, which is nice. One less dependency, fantastic. You kind of have to wrap your existing classes with OpenAPI's library, but that's okay. I can live with that. And then again you get back instances of your class, which is nice. But you still kind of have to do like this glue code, I guess, mapping the functions that it wants to call back to actual functions in your code, which is, it's not the end of the world, but it would be nice if it could just sort of call it automatically for you as soon as you call it, and then you can define your own guardrails and stuff as part of the framework that you use. And that sort of leads me to this section, agents with Semantic Kernel. So what is Semantic Kernel? First of all, I guess it's an open source library from Microsoft that lets you build AI agents, and it lets you integrate the latest AI models. And the thing that's nice about it is it has support for C#, Python, and Java. So we at Vena, we use all three of these, I guess, technically. So it seemed like a nice fit. Very hand-wavy explanation of what an agent in semantic kernel is, at least in their framework. I'm using their terms, but you would give an agent a persona. So this is like your system message. This is meta prompt, whatever you want to call it, that sort of sets the rules of what your agent can do, how it should respond, blah, blah, blah. There's also the concept of a kernel, which is like, I guess, like a dependency inversion container where you can add different AI services. So it doesn't just have to be like Azure OpenAI. You can give it, say, a set of different LLMs it can call, and it can internally figure out what LLM is the right one to use for whatever task. They call their functions or tools plugins. So it's the same thing. A kernel has access to multiple plugins where each plugin is a set of native code in your code base or remote APIs. You can sort of do either or. You can give it classes in your code, or you can give it like a API doc of remote services you can call. So either or. They're all plugins. And planners, this is like workflows that the semantic kernel team provides that let you plan out more like complicated tasks, and they have their own sort of internal prompts that help build out these structures. But a lot of it is now superseded with like parallel function calling, which is now their de facto planning method. So they just use that typically, and they recommend that. So initializing a kernel, this is just very straightforward boilerplate stuff. You instantiate an instance of the kernel, you give it an ID. In this case, I'm giving it the capability to call Azure OpenAI, and there's some info there. And then when you want to give it plugins that a kernel has access to, you would give it a class, and then you would annotate it with like special annotations that are provided by the library. So this is the same thing as like the pedantic field descriptions, but sort of more tightly integrated with semantic kernel. And the reason why they have this is that Yeah, the main sort of selling point for semantic kernel is that it bridges that last mile that I was talking about of like having the framework call your code for you so that you don't really have to like do all that glue stuff, which is I guess a little bit tedious, but it's just nice to have less lines of code in your thing. So yeah, that's how it bridges the gap. It has like the annotations around each of the methods that are available to be called by the agent. And then under the hood, it uses parallel function calling as sort of the default planning implementation. I'm just going to go. Oh man, this is a lot of code. So I mean, a lot of this is just like setup stuff for calling the agent. So this is just like adding user messages to the chat history so that you can pass it to the chat completion. So under the hood, this is all just calling the chat completions API. So there's a bit of like configuration here to tell it to use auto function calling. Here's where you sort of give it the plugins that are available. You can give your agents names and then like general instructions. So in this case, it's just a agent that will return information about menus and prices and what have you. And then when you actually invoke it, you'd get back sort of the assistant message, but under the hood, it's doing all the work of like calling the functions, including the function responses in the chat history, and then it's using all of that information to synthesize these assistant messages. So it's to the user, you don't have to show all the behind the scenes stuff, so for this example, like what's the special? Like this probably involves some kind of function call behind the scenes because the AI wouldn't know what the specials are or what the prices are. And it's sort of invisible to the user. But if we, I'm just going to share from this notebook actually. If we just peek under the hood, you can print out what the chat history is, because every time you invoke the kernel, it'll sort of automatically append what the function calls were, what the function responses were, and it's nice, I guess, from like a debugging or just a curiosity perspective. You can see that, hey, the model determined that you want to call the menu.getSpecials function, and then the function result was that, and then the assistant returned the answer because it had the information, and it'll sort of go through all these steps for you and include it in the chat history, and it's sort of up to you whether or not you want to include that or expose that to the user. Yeah, I already talked about that. And then this slide is called the power of friendship because it's dangerous to go alone. So semantic kernel has the concept of agent group chats or what have you, where multiple agents can work together. So ideally, agents should be, I guess, good at doing one thing. What's the Unix philosophy? Do one thing and do one thing well. Ideally, but who knows how these things are actually working in production. So the kernel still serves sort of as the core foundation for implementing this functionality, but the key takeaway is that a bunch of different agents can work together, and then they can also prompt the user for input as to participate in that process, because at the end of the day, the whole system is reacting to what chat history you put into each chat completion call. So depending on how you construct that, you can get very, very different behaviors. So how do you configure an agent group chat? Here's another example that I'll show over here. I've got two agents. One's an art director, one's a copywriter, and the goal is to have a copywriter produce a slogan for a new electric car, and it's the art director's job to be like, yes, good copy, or bad copy, and then yeah, a lot of these are like abstractions provided by the library, but it's nice that they're thinking about this and trying to support a whole bunch of different use cases. And the other sort of interesting thing about this framework is the concept of termination functions and like selection functions. So if you've got a group chat going, how do you know when the agent is done? How do you know when you've accomplished a task? So there's like the very simple example of that we have here is that you just give it another prompt. So you define just in English whether or how would you know if the copy is approved? So you just give it the whole history, and then if it seems like there's consensus, then you return yes. This is obviously like a very flaky example, but there's all sorts of different ways you can tell an agent group chat to stop. This is just one of them. Selection functions are ways you can define order for your agents. So in the previous example, we have a copywriter and like an art director. You typically would want the copywriter to go first to like throw out ideas, and then you want the art director to go next. You would, I guess, you describe it in English. So in this example, you tell it, the participants in the group chat, and there's rules here to say that the copywriter should go first, and then after they reply, it's the art director, and then you sort of describe this in English, and then internal to the framework, it'll use these two prompts to sort of gauge whether to switch control to the other agent or to end the conversation entirely. So yeah, these are two ways where it does that. And then you would instantiate a group chat, again, by passing in the agents themselves, and then the termination strategy and the selection strategy. And then after you run everything, you get something like this. You get back a user that's asking for a slogan for electric cars. You get back pairs where it sort of goes back and forth until that termination function that we were looking at before determines that, hey, this slogan's pretty good. So what did it land at? Quiet power, unrivaled journey. That's pretty good. I mean, I don't think I could come up with a better slogan for an electric car, so I'll give it to that one. And that, I believe, is the last slide for agents. I'll pass it over to Shaheen, and she'll talk about Retrieval Augmented Generation.
Kevin? Awesome, thank you, Kevin. So just to sort of recap everything we've gone through so far, it might be helpful to look at this diagram. Everything that we've talked about so far is how do you talk to an LLM and make it do good work for you. We've talked about like agents, we've talked about structured output, we've talked about semantic kernel, we've talked about what is a user message and a system message. But if you look at this graph basically represents like pretty much the only productionalizable thing you can do with Gen AI. So, and everything we've talked about so far is in this step 5, like how do you talk to the LLM to get a good response. But your LLM can only give you a response that's as good as the content you give to it. So if you have an application that is serving some specific need, and in our case, it's FP&A, so it's financial planning, analysis, etc. That is special knowledge, and on top of any financial terms and equations and whatever they teach you in accounting school, there is also stuff about the specific user. And what does their data look like? What does their revenue look like? What does their hierarchy look like? And so on. And that, to cover that, this is what is used, basically the rest of the steps. So I'll quickly go over kind of like this diagram. So you have your raw data sources or your corpus or whatever you want to call it. It's basically like a library of information that you want to specialize your bot to be able to understand and work with. You need to do some clever things to extract useful pieces out of it, given a query. You like do embeddings, you can do chunking, etc. There's a thing called vector databases, and I'll talk in more detail about all of these steps, where you can store all your embeddings or all your vectors, and then given a question, you can do some basically like matrix multiplications and clever math to figure out what is the most relevant information out of like this huge body of information that you have to answering your question. Again, you've probably heard the term like all you need is attention. The thing about attention is it's limited, so you need to make sure that you select the good information to pass into your LLM so that it has the best chance of helping you in any way it can. So with that, RAG, Retrieval Augmented Generation. What this basically means is it's a search technique. It combines retrieval-based and generation-based model techniques, so that you both have the conciseness, cohesiveness, answering capability of a generative model, as well as the added value of being able to retrieve accurately and relevantly. So with that, let's first talk about what this thing is. Or actually, I guess, do folks here know what vectors are and things like that? Yeah, okay, cool. So yeah, vector databases is just, it's a cloud thing you can use to make working with vectors easier. You can do like quick searches like similarity. You can manage embeddings, etc. And vectors, like some good things you can do with vector databases, similarity search, high dimensional data handling, scalability. You can pull up shards and increase and decrease, etc. And it's really easy to work with machine learning pipelines, etc. Some other things you might have heard of that use vector databases would be like recommendation systems. If you're like on Netflix and it's giving you a recommendation for what to watch next, it's probably using some sort of clustering using vector databases that says like, oh, these shows and TV things are close to the cluster of things you like, so maybe you'll like this next. Image and video retrieval. So like given an input, if you're like creating like stock photos, etc. Natural language processing, this is what we use it for. So like these vector databases to help with semantic search, answering questions, document retrieval, etc. And fraud detection, vector databases are really good at their whole point is like seeing what's close by and seeing what's an outlier. So they're really good at fraud detection. So a little more about vector databases. This little program basically takes in these sentences, which in this context would be like my corpus. And I'm trying to ask this corpus, oh, what is the closest sentence to how can I make a good breakfast? And as you can see, it calculated, oh, to which part? Just make the text larger. Okay, 1 sec, sorry. Is that better? All right, so say you have like these sentences, and this is your query. So now what's going on behind the hood is we first turn this into a vector. So at Vena we use like, I don't know, text embedding, small or something like that. So you have like a vector, many dimensions, and then you can do like simple to complex algorithms to find out what are the closest vectors. You can do like literal geometric distance, Euclidean distance. You can do like cosine similarity, etc. And then after doing that, these are this was the calculation. These were the vectors that were closest to my query. How can I make a good breakfast? It picked omelet, perfect coffee, cheese omelet, etc. And it ignored the things that were unrelated. The thing about vector databases is they're really good at capturing the semantic meaning of the sentence. So that's what it did here. So if you want to visualize it, we can do some dimensionality reduction. So vector databases, or like vectors, they have a lot of dimensions, and it's kind of hard to picture it in your head what's going on. So you can use something called PCA. It basically just means it's going to try to find the orthogonal directions that have the most variability and kind of cut off the rest. So with the same example I used a PCA algorithm here to reduce it down to two most relevant directions here. So PCA1, PCA2, there's like a 90-degree angle between them. And then you have how can I make a good breakfast? And these were the plots. So we have omelet and cheese omelet and breaking fast and going slow because it's like semantically similar to breakfast. And yoga practice is also not too far off, even though it's not exactly breakfast. You would want to use PCA if you say, for this sort of a thing, like it makes, it can keep a lot of the semantic meaning and the useful stuff of your vector and like reduce computational costs, etc. It also helps you reduce bias sometimes, like maybe you're, if you like use all the vectors, maybe you're over-indexing on some dimensions that you don't need. So using PCA can be helpful to kind of cut down. So in 3D, what does this look like? Same example. If you hover over, it's kind of hard to see when zoomed in, but yeah, so this is, I just did a PCA of 3 instead of 2, so I get like this cool little graph, and I can kind of judge my distance from a given sentence to this red dot, which is my query. And you, of course, don't need to do a reduction. You can just use all of the vectors. And if you're ever reading like papers on this sort of a thing, you'll probably see a lot of heat maps that are kind of just giving you like a breakdown of, oh, these are all the similarities. And if you look at this, there was actually an interesting example here where something would be, say, something would be listed as like more relevant when you include all the vectors, and then if you drop some dimensions, it'll be less relevant. And that cutoff point is important in not having like unnecessary noise in your data. Okay, so that was a lot. I guess quick stop. Do folks feel like you have any questions, anything you want to urgently get off your chest? We will probably do like a Q&A after, but feel free. Oh yeah, we'll share the, we have like a repo, so we'll share the GitHub link at the end. Yeah, you can totally get a copy, but anything else about everything we've covered so far? Okay, if not, oh yes, go ahead.
How do you guys get up to date with changes on the models? How would you do if you have a production application and then you have a new model? How would you?
Yeah, that's a good question. So the thing about models is they do a lot of similar things, just better and better, or like slightly different every time. So say like recently we made a switch from 3.5 to 4.0 for a lot of these tasks, and all we had to do is just kind of tune in on some of the things that we know 4.0 does worse or better, and make sure that we are covering for it in other ways. And it's a lot of benchmarking and making sure that you don't miss any gaps or you don't disrupt the user experience. And like, I guess Kevin touched on it earlier, but it's also a lot of vibe checks. You just like kind of like ask it weird questions and try to really play with it and see if something seems off. So while benchmarking gives you a lot of the picture, you kind of really need to get an intuition for how it's changing with every iteration. Yeah. Oh, sure, yeah. Any other questions about what we talked so far? Yeah.
If you could just summarize again this before moving. If you could.
Here, do you want to use this one? We have another one.
Yeah, I've got one here.
Yeah, simple question just before moving on. If you could summarize the relationship between the data you might get back from a vector database search and how that plays with your LLM. Is it usually you fetch stuff from your vector DB and then afterwards feed that into the model?
Sure, yeah. I'll just quickly go back to that nifty little diagram that I took off the internet. So you're basically asking about what a summary of this, right?
Yeah, so I guess if I were to put into my own words, you have some proprietary knowledge, in-house knowledge, and you may save it in a vector database. And to get the most out of your LLM search or interaction, you would then have that as context to an LLM prompt. Is that correct? Am I understanding it correctly?
Yeah,
Okay. Okay.
basically, yeah.
Okay, thanks.
That's exactly it. Anything to add, Kevin?
Yeah, I guess just like a simple example from our current workflow is that we'll do like a top 3 sort of lookup from our vector database, and then we'll use that as sort of like as a few shot examples. And then internally, like one of the other frameworks that we use is called Promptflow, and they use Jinja for templating. So when you're building out your prompt for your chat completion, it's a lot easier to work with like a templating language. So you can do like loops, if statements, what have you. So sort of build out the examples that you give to the LLM in a much more structured way, because it's if the prompt that you're giving to the LLM is like hard for a human to understand, it's probably hard for the LLM to understand. So formatting is important. So having a templating engine like Jinja or I don't know what else is there, handlebars, whatever, is an important tool to have when you're fetching examples from like a vector database.
Any other questions? Okay, if not, let's go into hybrid search. So I guess, again, just to recap really quick, we've talked about what embeddings are, we've talked about what vectors are, we've talked about like semantic search you can do with vector databases. But the thing about having like a productionalized app is you need to be fast. You can't be racking up like intense amounts of costs by doing everything always like to the nitty gritty. And sometimes it helps to just kind of mix and match the quick and dirty approach with the more detailed approach. And that's kind of where hybrid search and re-ranking come in. An easy way of understanding it is basically like you do like a quick spray to find the things that are the most relevant. Say like you narrow down based on metadata or keywords, etc., relevant to a query. And then you go in with your cosine similarity or semantic search, etc. And then you do a re-ranking, taking your quick and dirty approach and your deep vector DB involving approach, and then you use some clever algorithms to take the results of both into account to get to your final answer. So this is basically like kind of just cutting down computation time, and in some cases actually getting better results, because sometimes just understanding the question is not all you need. So we'll go over a few examples of how we have used hybrid search. So first one, metadata filtering. We actually use this to support multi-tenancy. So it is pretty complicated to store like data for different customers, and then when you're searching for a question relevant to a particular customer, you don't want to be also looking at things that don't belong to that customer, because that's useless to you. So you can just like put that in the metadata, like this is my customer ID, filter off everything else, and that kind of narrows down your search space. Or like another example of that would be here, like I have, this is my corpus. Can you folks see? Should I make it bigger? Okay, so this is my corpus. Say I want to filter based on these keywords in my metadata search. So it's conservation, sustainable, climate, renewable, and what the output will be is first, all my corpus is going to be filtered based on the metadata. Then, and you can also see what the cosine similarity ranking would have looked like without the metadata filtering. But with the metadata filtering, you have like far less to work with, and it's easier to see what are your top 3 examples or what you should pick. So in this case, we had a focus on words that were like conservation, sustainable, etc., and we have a ranking and like cosine similarity to the given query. Another interesting use case that we came across was, so sometimes users will ask a question that is so proprietary or like so specific to their hierarchy that it doesn't make sense to the LLM. For example, you want to get information about account number 4000. So you'll type like, give me the highest revenue for 4000. And so the LLM, or even with like semantic learning and all of that, it's like kind of reeling, oh, what is 4,000? We don't know. So that's where like some other quote unquote like dumber methods of search come in. Full text search is one. Full text search basically like will do exact matches to see like where in the body of your corpus do these words come up. So if we like have in our vector DB like account 4000 mentioned, it will kind of zoom in on the fact that there was a 4000 there and use that as like in the step where we used metadata filtering before. So an example of this would be maybe like the trigram index. This is a useful way of accounting for like user error. So if the user just like mistypes or like spells something wrong, you would want to break up your query into like pieces. So instead of saying like conservation, it'll be like conservation. So even if they get some of it wrong, you'll still find a match, and that's called like fuzzy search. And the same principle applies to the 4000 thing, because they didn't give you enough information for you to know where you should be looking, but they give you the 4000. So you go with the 4000 and you find the exact match in your corpus, and then you go from there. So the way it would look like, say in this example again, I have like my document or my corpus. I have my queries, and you'll see like it's very poorly spelled. Hey, I know AI, but not spelling. So now, as a result of this, I can see that I got conservation efforts for rainforest, even though I spelled conservation and environmental wrong, and so on. And I guess another part of this we can look at is what does it, like in the 4000 example I just told you, where the user's like specifically mentioning a word that doesn't make sense. So say in my corpus I had words like the user is saying 4000, this is my query, and my corpus has like account 4000, something 4000, and then a bunch of other like finance related data. So what full text search does, and I'll show you the difference between just semantic searching and with full text, is that it'll pick up on the 4000 because it was in the corpus. And then if you look at the vector search results, so this is without any full text, the 4000 is not being picked up on. So like it's pretty low, and it's high on like some other things here. But that's bad, right? Because you want information on your account 4000. So if you do hybrid search now with both full text and with vector search, you end up with something like this. And would you believe it? It's after re-ranking, we ended up on the right track again with 4000s being the highest. So yeah, understanding is not the end all and be all. Sometimes you just need some simpler techniques to make sure you're not missing out on like key information. So yeah, that was how to make your LLM have the right information, basically. So we've talked both about like how to talk to your LLM, and then we've talked about what to say to your LLM. Any questions? Oh, I guess Kevin, did you want to talk about Promptflow or anything like that? So we can also talk about testing and how to benchmark and all of that. We have a section for that, but we're trying to be mindful of the time, so let us know if you're interested.
Yeah, sorry, I'm generally curious because I haven't really seen this in production, so I'm just kind of wondering, like, because we usually have like testing for, software and stuff like that before we release to production. Because this is like there's more probable results, right? Like sometimes you're not maybe, because I don't know, I haven't really touched this, so maybe you're not sure exactly what the results you get. And usually like testing, you're kind of comparing it with an expected predictable result. How do you do testing for like a RAG system or like something like this where it needs to be in production and you need to have some kind of expectation that it works?
You want to just do the rest of the talk?
Yeah, we can do the rest of the talk that goes over that if you'd like. Yeah, sure.
We were going to leave this part out because we didn't know if you guys like testing, but apparently one of you does, so thank you. Shout out to the guy who likes tests. Yeah. All right, maybe I'll just, oops. Oh, that's you. So I'm glad you asked, audience member. So here at Vena, I think we might have mentioned this before, but we use another Microsoft library called Promptflow. It's again an open source suite of development tools, so you can define your whole LLM application with this tool. But typically, we're using it mainly for benchmarking. And sort of their elevator pitch for it is that you would define your project as sort of like a directed acyclic graph of different LLM calls or Python methods, and it all sort of flows in one direction and returns an output. And so if you couple that with like different lookups to vector databases or calls to LLMs that produce structured output, you can sort of run your benchmarks against those outputs. And internally, it's been, I'm not gonna lie, it's been difficult trying to get like good benchmarking data that we can actually trust. So we've experimented with the LLM like generating data for us to test against, but it's not perfect. So we just threw humans at it, and then we got kind of a good benchmarking data set. But there are still like vibe-based checks in there. So here's just like a really tiny picture of what Promptflow looks like. Each of these nodes can either be an LLM call, it can be a Python function, it can be building out the prompt template, or it could be anything. But the nice thing about this tool is that you can run it directly in VS Code as a plugin, or you can run it in the cloud. So you can do all your benchmarks in the cloud as well. But for us, we typically just run it all on our computers because it was just faster. And if we look at, I mean, I'm not going to run this, but the typical way you'd set up an application with Promptflow is that you'd have a flow that runs your core code. So so in our case, it's a Q&A bot, and the way that we do the Q&A part is we look up stuff in the vector database, and we still have to build like a query expression. So under the hood at Vena, we have an OLAP cube, but it's not really a known OLAP cube query language. Ruhi, what's the language called? No, the official one. Oh yeah, it's not MDX. So MDX is like the official language that the LLM would probably know about, because this is an established standard for querying OLAP cubes. In our case, we developed our own language. So for our Q&A bot, we had to sort of do some of that mapping to pick out which members in their cube are relevant for querying our cube. And that's where we can benchmark our data, because the output of the predictions would give you back JSON or basically a query string that you can compute what the confusion matrix is. So it'll tell you like what the true positives are, what the false positives are, all four of those different numbers, and from there you can sort of gauge how accurate you were to what the correct query was in your system. There's still sort of that last mile of like, even if you have the right data, do you have the right answer? We still don't have an answer for that. It's hard to do with the tools that are out there. Maybe there's a better tool out there now. Promptflow provided a few out-of-the-box ones that were kind of okay, but didn't quite capture the sort of nuance that we were looking for. So we're on the hunt for better eval methods for these tools always, because there was some other person that was asking, how do you ship a new version of a model? It's through benchmarking and like gradual rollouts. Yeah, benchmarking, vibe checks, and gradual rollouts. We have like a feedback system, but part of the app is actually like putting some of the power in the user's hands. So whenever they start the trial with the app or whatever, they go through a vetting process. They'll have a lot of the questions that they'll usually get from their CFO, and these are the same questions every quarter, right? So they'll go through these questions with our tool and sort of gauge on that whether or not they want to give it to their finance team. And then it's between that and sort of internal to our system, not even related to AI anymore, but in the app you can add more rules to your system. So these rules would go into the vector database, and then it sort of improves over time if you've got a really, really keen CFO that wants to improve this bot. So yeah, that's how we try to tackle it.
I also wanted to say one thing we did for the hallucination problem was try to use semantic kernel essentially. So if you limit what are the things that the bot can do, then you have like a better idea of where to look out for hallucinations. So like for math, for example, like we don't trust the LLM to do math, that sort of a thing. Yeah, so that helps quite a bit.
Yeah, that's a good point. Yeah, hopefully that answered your question. I mean, and then I guess the other nice thing, maybe this would still run. The other nice thing that I want to call out about this library is that it has, oh shit, not that. Where is it? Maybe this will work. Come on, baby. Oh yeah, okay. So when you define like the DAG or whatever, each node is instrumented with open telemetry semantics or whatever. Yeah, it is. And the nice thing about it is it really helps from like when you're developing these flows in the first place to see what the inputs and outputs are of each flow, and then it all sort of feeds into this system, which it all runs on your computer. So I think there's like a SQLite database backing all this somewhere, but you can see exactly like what went into each node, what each flow returned, so that when you benchmark, you give it like 200 questions, and then for each of those questions, you can write another flow that gauges accuracy. So this would be a flow that you'd write, say, just purely with Python, comparing the output of this flow and like what you know to be the ground truth is, and then at the end, the framework also lets you like perform like aggregates the results, and you can report this wherever you want. So when you run this in Azure, it'll write it to like a data set that you can use later. In our case, we're just writing it to a CSV file to track our performance as we develop stuff. And yeah, I'm glad that ran. I didn't think that would run. Here's a picture of some boxes. And we're just tried to visually describe all the things that we talked about. So where did we start? We started with chat completions. We didn't really talk about prompt engineering because I trust you guys have done enough of that. Talked about structured output and tool calling, and that's sort of under the umbrella of chat completions. And then there's this whole wide world of external data and existing source systems that in your existing apps you might already have good logic, existing logic to call. So these are vector databases, these are your relational databases. There's GraphRag now, native code, and of course remote APIs. So if you've got like external systems that you want your API or LLM to call, This is that bucket, and then I guess agents can wrap all of these things. Sure. And then the most important thing, testing, benching, benchmarks, and evaluations. Shout out. Yeah, testing. And I believe that is the last slide. Code and slides can be found in that tiny URL there. Thank you.
Awesome. Thank you so much. I know that was one question, and but unfortunately time does not wait for us. But we will use the rest of this time. They will still be around, so if you have any burning questions, feel free to, continue the conversations. Don't forget that there is a table set up back. Oh, I don't know. Are they going to still be there? Yeah, for folks who are interested in Vena. But yeah, another round of applause for Kevin and Shaheen. Thank you so much for all of that. Can you go back to the slide? Our slide, yeah. We're going to be. Oh, it did not get updated. Okay, there we go. Oh. So when we kick you out, we are going to move over to local public eatery at Liberty Village. It's I know, 9-minute walk. Yeah, but we can, it's a bit far, but I believe in us. We can walk 9 minutes. We will survive, and we will continue the conversations there. But yeah, for now, thank you so much for being a wonderful audience. Thank you so much again. And yeah, we'll continue the conversations here until we kick you out. Thank you.